All right, let's jump right in. Today, we're going to talk about something that's absolutely fundamental to writing clean, scalable Go code. We're talking about the strategy pattern. And trust me, it's the thing that's going to save you from those monster if-else chains we all hate.
So think about it like this. You open up your GPS. You have one destination, right? But the app gives you choices. You can take the fastest route, the one that avoids tolls, or maybe you want to skip the highways altogether. The destination is the same, but the strategy to get there is totally interchangeable. Just hang on to that idea.
Because your code has the exact same problem all the time. Let's say you need to export a report. On weekdays, it needs to be a PDF. On Fridays, it's got to be a CSV. But wait, the finance team needs an Excel sheet. You know where this is going? It leads straight to this mess. A long, brittle, fragile chain of if-else statements. We've all been there. We call it if-hell. And the worst part, every single time a new request comes in, like, hey, can we add a JSON export? You have to go back, crack open this delicate code, add another else if, and just pray you don't break everything else in the process.
Well, the strategy pattern is the answer. It's like a surgical tool for fixing this exact problem. It really is a blueprint for making your code flexible and, most importantly, robust.
So how does it work? Well, it breaks the whole thing down into 3 simple roles or actors. First up, you've got the strategy interface. Think of this as the contract. It just defines what can be done. Something simple like export report. Then you have your concrete strategies. These are the actual implementations. This is the how. One strategy for PDF, another for CSV, a third for JSON. And finally, you have the context. That's your main application code. And the beautiful part is, it only knows about the interface, the contract. It has no idea which specific implementation it's using at any given moment.
And this picture shows the idea perfectly. You've got this central PrintStrategy interface right in the middle. It's like a universal socket. Then you have these separate, totally interchangeable modules, a console strategy, a file strategy, a network strategy, and they all just plug right into that same socket. Your main program just holds onto the socket, and it can swap any of these strategies in and out without its own code ever having to change. It's brilliant.
Okay, enough theory. Let's actually see this thing in action. We're going to take that horrible if-else mess and refactor it into something clean and maintainable using this pattern.
Okay, check this out. On the left, that's the before. That's the tangled if-hell we all know and dread. If you change one of those paths, you risk bringing the whole thing down. Now, look at the right. This is the after, and I want you to focus on that one key line, activestrategy.print. That's it. That line never changes. It doesn't matter if we have 2 strategies or 200. The code that calls it stays exactly the same. It's simple, it's clean, and it is stable.
Now let's talk about a really important Go-specific detail, because this trips a lot of people up. Go doesn't really do classical inheritance. It prefers composition, and it does that through embedding. So let's say we have a text_square struct, and it embeds another struct called printOutput. The text_square now gets all of printOutput's fields and methods. But, and this is the part you have to remember, this is composition, not inheritance. In other words, a text_square has a printOutput. It is not a printOutput. It's a subtle but super important distinction in Go.
So at this point, you might be thinking, okay, this is a neat academic pattern. But what if I told you it's not academic at all? What if I told you it's actually one of Go's hidden superpowers and it's foundational to the entire language?
Yeah, that's right. The truth is, if you've written any Go at all, even just a hello world, you have already used the strategy pattern. You've probably used it thousands of times, and you didn't even know it. And here it is, the io.Writer interface. This is arguably the most used interface in the entire Go ecosystem, and it is a textbook example of the strategy pattern. Think about fmt.fprintf. The first thing it takes is an io.Writer. It doesn't know and it does not care if it's writing to a file on your disk and network socket, standard out, or just some buffer in memory. Each of those is just a different concrete strategy for the one single action of writing.
And believe me, it does not stop there. This pattern is baked into the DNA of Go's standard library. The sort.Interface, that lets you plug in different sorting strategies. The http.Handler, that's just a strategy for how to handle an incoming web request. Even the database/SQL package uses this exact pattern to let you swap out drivers for Postgres or MySQL or SQLite without changing your application logic. Go is literally designed around this philosophy.
But, you know, being a good engineer means knowing not just how to use your tools, but when to use them. A great pattern applied in the wrong situation is still the wrong solution. So let's talk about when to use this, and just as importantly, when something simpler is actually better.
So in Go, you don't always need to go for the full heavyweight interface. For simpler cases, a function type is often way more idiomatic. You should use a simple func type when your strategy is stateless, and it's really just a single operation, like a quick one-line string transformation. But you should absolutely reach for the full interface-based strategy pattern when your strategy needs to hold on to some state, like a file path or a database connection, or when you need a group of related behaviors, like compress and decompress. And finally, when the logic is just complex enough that you really need to test it in isolation.
And this pattern is an absolute workhorse in real-world production systems. I mean, think about payment processing. You have strategies for Stripe, PayPal, bank transfer, all implementing the same charge interface. Or logging backends, where you can swap between logging to the console, a file, or syslog. Authentication, perfect for switching between JWT, API keys, or OAuth. It's a game changer for things like A/B testing, where you can flip a feature flag and switch out a core algorithm without a single redeploy. The versatility is just huge.
So as we start to wrap this up, let's just boil it all down to the core philosophy. The strategy pattern, at its heart, is about one simple, powerful idea, separating the what from the how.
And this leads us directly to one of the most important principles in all of software engineering, the open/closed principle. It means your code should be open for extension, but closed for modification. The strategy pattern is the perfect embodiment of this idea. You can add brand new functionality, new strategies, without ever having to touch the existing, stable, well-tested code that uses them. This is how you build systems that can grow and scale to millions of lines of code without collapsing under their own weight.
So we've seen that the strategy pattern is perfect for swapping one algorithm for another. But what happens when the problem is a little different? What if you don't need just one strategy, but a whole chain of them, where each one gets a chance to handle a request one after the other? Well, that's where another incredibly powerful design pattern comes into play. But we'll have to save that one for the next time.